Alright, so what do we've got here? We've got a function. Okay, so a is a positive value, so it's going to be opening upwards. And it's in factored form so we could find out what the roots are. Let's just sketch what we think that looks like so we can kind of get a visual. So the roots are at, let's just say this, 2 and 8. Okay, so that's where it is. It's opening upwards, and let's see, 1, 2, 3, 4, 5. So somewhere right here is our axis of symmetry. Okay, and we know that, you know what, it doesn't. We don't know where this minimum is right now, but we can just make a drawing that's not to scale. So it goes down here. We know it's opening upwards, right? And we've got this vertex somewhere down here. And it's going to open up there. Okay. How do we know that? Well, we know that the A value is that. And what's the average of 2 and 8? Is 5, right? So we know that the value here is 5. So x equals 5. That is our axis of symmetry. We can see that right away. I didn't have to do any algebra for that. This is the nice thing about this. Okay. Now, so how are we going to determine what the minimum value is at this point? Well, we know the x value is 5. So what is our y value? All we have to do is substitute the value for x for that. Okay. So let's find out what that is. So this is just f of 5. Right, equals 9 times, and I'm going to substitute 5 in for x. So I've got 5 minus 2. So that is equal to 9 times 5 minus 8 is negative 3. And then 5 minus 2 is 3. Okay, so that is equal to negative 81. Okay, now, does that seem reasonable? If you think about how many units over we are from the center, we're 3 units there. So if we were to go 3 units over, and if it was just like, for example, y equals negative x squared, okay, so that would go down 9, because 3 squared is 9, and since this is the a value is 9, it would be 9 times that, so that would be negative 81, right? So what is the minimum output? The minimum output is 81, because that's the minimum y value, and that's got to be right here at the vertex.